let's write first everything what we're supposed to find in this problem in order to do not miss anything. So I'm going to write find, and we have to find R total. We have to find I1, I3, I5, I total. We have also VA. We're supposed to find VB, VC. We're supposed to find P2, P3, and P6. Okay, we have to find all these quantities. So for some of you this circuit can look kind of complex, so the very first thing which I'm going to do, I'm going to redraw the circuit in order to make it look a little bit simpler. So this is my point A. This is my point B. Okay, so please notice that point B is my ground, right? So this is also my point B over here. So I'm going to draw the voltage source over here. So this is point A, and this is my point B. Point A is connected to resistor R1, is connected to resistor R2, and goes to point B. So I'm going to draw something like this. This is my R1, and this one is R2. Next, point A is also connected to resistor R3 and is connected to B. So I have resistor R3 over here. This is my R3, and now I have also resistor R4, which is connected to point A and to point B. So this is my R4, and I have also resistor R5 connected to A and is connected to R6 and is connected to B. So I have R5, R6, okay, so this is my circuit, and this is of course my voltage source. So what we're supposed to find? We're supposed to find R total. So first I'm going to find the equivalent resistance R12 and equivalent resistance for these two resistors. So I have R12 is equal R1 plus R2. Remember formula first. R1 is equal 3 kilo ohms plus R2, which is equal 5 kilo ohms. This is equal 8 kilo ohms. Next I'm supposed to find R5, 6. R5 plus R6. R5 is equal 2 kilo ohms plus 1 kilo ohm. This is equal 3 kilo ohms. Next, in order to find total resistance, I'm going to use the formula R total is equal 1 divided by open parenthesis 1 over R1, 2 means these two resistors together, plus 1 over R3 plus 1 over R4 plus 1 over R5, 6. For those of you who do not see what I'm doing, simply redraw the circuit, and these two resistors together we call R 1, 2, and after that we have R3, we have R4, and we have resistor R5, 6. Okay, so that's why I'm using R12 and R56 in the formula like this. Okay, so now we're supposed to simply substitute the variables by the resistances. So if R total is equal 1 divided by, open parenthesis, 1 over R12 is equal 8 kilo ohms plus R3, which is equal 4K, plus 1 over R4, which is equal 2K, plus 1 over 5, 6 is equal 3K. And this is equal 1 divided by, open parenthesis, 1 divided by 8 exponent 3 plus 1 divided by 4 exponent 3 plus 1 divided by 2 exponent 3 plus 1 divided by 3 exponent 3, close parenthesis, equals 827.58 ohms. 827.58 ohms. So this is my total resistance. The problem is asking me to find the total current. This is total current over here. See, this is the current which goes through the ground. Okay, so this is the same current which goes through the circuit, okay, because whatever goes to the circuit has to get back to the ground. So I total is equal voltage source over R total. Voltage source is equal 5 volts divided by R total, 827.58 ohms. So this is equal 5 divided by 827.58. This is equal 6.04 milliamps. 6.04 milliamps. This is my I total. Okay, so far we found R total and we found I total. Next we are going to find I3. I3 is the current which goes through resistor R3. Okay, so this is very easy to find because the voltage across resistor R3 is equal to voltage source. Don't forget that this is parallel circuit. Okay, so this voltage is across this resistor. Okay, and let me just remind you that KVL says that voltage source is equal to V1 is equal to V2 is equal to V3, right? And is equal to V4. But in our case, I'm supposed to write this is V1, 2, V3, V4, and this is V5, 6, okay, in order to be clear. So voltage across these two resistors is V1, 2, V3, V4, V5, 6, okay, because this is the parallel circuit. So what I have to do right now, I'm supposed to find I3. I3 is equal voltage source over R3. Voltage source is 5 volts over R3, which is equal 4 kilo ohms. 5 divided by 4 exponent 3 is equal 1.25 milliamps. Okay, so this is my current I3. Next I'm supposed to find I5. I5 is also equal to I6. Okay, the current which will go through this resistor will also be equal to the current which goes through this resistor, because this is the same current. Okay, and I'm going to find this by, again, using Ohm's law. This is voltage source over R56. Okay, total resistance of these two resistors. You cannot divide voltage source by just one resistor. You're supposed to divide by the total resistance of these two. So if voltage source is equal 5 volts over R56, 3 kilo ohms. This is equal 5 divided by 3 exponent 3. This is equal 1.67 milliamps. Okay, so this is my I5. So we found I3, we found I5, and we found also I total. Right? So next we're supposed to find VA. VA is the voltage at this point. Please notice that this is the voltage between this point and ground, and this point is connected directly to what? To the positive terminal of my power supply. So I'm supposed to say that VA is equal my voltage source, and this is equal 5 volts. This is my VA. If you want to find VB, VB is connected directly to what? To ground. See? This point is connected directly to what? To the ground. So voltage at this point is going to be 0. VB is equal 0 volts. VC is the voltage over here. This is my VC. VC is voltage between this point and ground. So this is nothing else, just the voltage across resistor R6. Okay, VR6. So what I'm going to do, I'm going to use, let's say, Ohm's law. So if VC is equal I6 times R6, where I6 is equal 1.67 milliamps times R6, 1 kilo. This is equal 1.67 volts. So this is my VC. I forgot to find I12, so let me find this right now. I12 is equal to I1. This is also equal to I2. This is voltage source over R12. Voltage source is equal to 5 volts over R12, 8 kilo ohms. So 5 divided by 8 exponent 3 is equal to 625 micro amps. So now we can find P2. P2 is equal I2 to the second power times R2. I2 is equal to 625 microamps to the second power times R2, which is equal 5 kilo ohms. This is equal 625 exponent 6 negative to the second power times 5 exponent 3 equals 1.95 milliwatts. Okay, we found P2. P3 is equal I3 to the second power times R3. I3 is equal 1.25 milliamps to the second power times R3. R3 is equal 4 coulombs. This is equal 1.25 exponent 3 negative to the second power times 4 exponent 3. This is equal 6.25 milliwatts. This is my P3 and P6. P6 is equal I6 to the second power times R6. This is equal I6. We found this is equal 1.67 milliamps to the second power over here times R6, which is equal 1 kilo. Okay, so this is equal again 1.67 exponent 3 negative square times 1 exponent 3. This is equal 2.78 milliwatts. 2.78 milliwatts. So we found all unknown quantities, so we can say that the problem is solved.